So topic 6, which is about the chemical energetics. In this chapter, we'll discuss a chemical energy change during a chemical reaction. So in terms of energy, we divide the reactions into two categories. These are the learning objective. So it's a very short topic. First, you have to learn about exothermic and endothermic reactions, and using the energy level diagram, you should be able to explain the exo and endothermic reaction. And the second part, how we can release the heat energy from uranium, from hydrogen. That is the second part. So describing the meaning of exothermic and endothermic reaction. So how we define the term exothermic reaction in endothermic reaction. So the term endo means in, and the term exo, it's from exit, it means out. And the term thermic, the term thermic refers to heat. Here also thermic refers to heat. So how we define the term endothermic reaction? So the reaction in which overall heat energy is absorbed, known as endothermic reaction, and the reaction in which overall heat energy is released or given out, we call them as exothermic reactions. So any reaction in which overall heat energy is absorbed is endo. A reaction in which overall heat energy is released, we call that as exo. Example, melting of ice. So what happened in a melting of ice? Example, you have an ice cube. So this ice cube, as it absorbs energy, it will turn into, it changes the state from solid to liquid. So originally it is solid, then it turned into liquid. But how this solid is turned into liquid? So this solid turn into liquid or convert into liquid by absorbing the heat energy, by taking out the taking in the heat energy. So when a substance change by absorbing the heat energy, what we call this change in terms of energy, we call that as endothermic reaction. But when you burn something, example, combustion or burning, so when you burn something, when a combustion reaction take place, you have a sample of coal, and when you burn a coal, there is a chemical reaction. Coal is reacting with oxygen, and when it react with oxygen, overall energy will be released. So if the energy is released or energy is going out from the system to the surrounding, what we call that reaction, we call that as exothermic reaction. So a chemical reaction can be endothermic, absorb energy. It can be exothermic, that releases the energy. Is it clear? The concept of endo and exothermic reactions? Anyone having a doubt? So reaction in which heat energy is given out. Exo, the reaction in which heat energy is absorbed, we call that as endothermic reactions. So examples of endothermic reactions: number one, when solid change to gas, or solid change to liquid, or a liquid change to gas, or a gas, a solid turn into a gas, or dissolving of a solid, or dissolving of salt in water. These are endothermic. That's and thermal decomposition. So examples of endothermic reactions: a solid turn into a liquid. Like first initially we have a solid, and that solid turn into a liquid. So how this solid will turn into a liquid? It is by absorbing the heat energy. So if heat energy is taken in, we call this reaction as endothermic reaction. Same way, when liquid turn into a gas, like this is a liquid we have, and we supply the heat energy, and this liquid boil and it turned into a gas. So if a liquid absorb energy changes into gas, so this change is also, in terms of energy, it is endothermic. Same way, a solid sublimate convert directly into a gas, that is also an endothermic change. Dissolving of salt, like example, you take a container and you fill it with water, and we add the crystal. Like example, we are adding a salt crystals. So when we add this salt will not dissolve by itself. What we have to do, we have to stir it, or we have to supply heat energy. So when we stir by using a spoon or a spatula, when we stir this, basically when we are stirring, what it provide energy, and when it provide energy, the salt particle move away from each other and move throughout the water, so the substance will dissolve. Is it clear? The concept of endothermic, examples of endothermic reaction. And the last one is called thermal decomposition. What is the meaning of thermal decomposition? The term thermal decomposition means when we have one reactant, the type of reaction in which only one reactant and there are more products. So when we have only one reactant and we have more product, we call that reaction as thermal decomposition. So we have calcium carbonate, which is also called a limestone. When we supply heat energy to the limestone is solid. So when we supply heat energy to this limestone, what we observe? We observe it changes into calcium oxide plus carbon dioxide. So we have only one reactant, that is calcium carbonate, and we have more product. The calcium oxide is one of the product and carbon dioxide is a second product. So when you have one reactant and more products are there, what we call this type of reaction, we call them as thermal decomposition. And thermal decomposition is always endothermic. Means it can only occur by supplying the heat energy. Is it clear the examples of endothermic reactions? So a solid convert into a liquid, melting is endothermic. liquid convert into a gas. Boiling is endothermic. Solid convert into a gas, endothermic. Dissolving a salt, when we add salt to water, we stir so that the salt particle can spread throughout the water. So in this change we supply energy, but how we are supplying energy is by stirring. That's why it is also endothermic. And thermal decomposition means whenever we have one reactant and more products are there, we also call this type of reaction as thermal decomposition, and it is always endothermic. Is it clear? The examples of endothermic reactions, anyone having a doubt? Then examples of exothermic reactions. If a gas turn into liquid, or a liquid turn into a solid, or a gas directly turn to solid, combustion, burning, combustion, and respiration. And the previous, we can add two more examples for endothermic. We can also mention electrolysis, because in electrolysis, we pass the current, we supply electrical energy. So all the electrolysis are endothermic changes as well as photosynthesis. Because in photosynthesis, what plants do, they absorb light energy and forming their food. Glucose and oxygen is formed by the help of sunlight. So these are examples of endothermic reactions. For exothermic reaction, it can be a gas turned to liquid, liquid turned to solid, gas turned to solid, combustion, burning, respiration, or chemical cell. So chemical cell, their reactions are exothermic, it releases energy. So if we have, like we have a gas originally, and this gas turn into a liquid state, and then that liquid freezes. Because gas, the particles are moving faster, they have more energy. So how a gas can convert into a liquid state and a liquid can freeze to form a solid? So gas turn into a liquid state by releasing the heat energy. So when the gas molecule release the heat energy, energy is given out, they turn into a liquid. And when the liquid molecules release the heat energy, they will turn into solid. So all these changes, gas to liquid and liquid to solid, are exothermic. Why exothermic? Because the energy is being released. Same with combustion. How you will identify whether a reaction is combustion or burning? So how to identify a combustion? If oxygen is involved as a reactant, as a reactant, and the substance is burned, we call that reaction as combustion reaction. So all the examples in which include oxygen as a reactant, say we have coal, it reacted with oxygen to give carbon dioxide. So coal reacted with oxygen to give carbon dioxide. How we can identify what kind of reaction is this? As you can see, oxygen is involved as a reactant. So if oxygen is involved as a reactant, so what is the category of this reaction? It will be a combustion. So in a combustion reaction, oxygen is always involved as a reactant. So if oxygen involved as a reactant, you can simply identify that this reaction will be exothermic. It will always release energy. Another example, if we say we have methane which reacted with oxygen or which burned in the presence of oxygen to give carbon dioxide plus water. So you can see the oxygen is involved as a reactant. So if oxygen is involved as a reactant, what kind of reaction is this? This is also an example of combustion reaction, and whenever there is a combustion reaction, it will always be exothermic. Is it clear? The concept of combustion reaction, when we burn a substance in the presence of oxygen, so oxygen is always involved as a reactant in a combustion reaction. So we call them as exothermic. The overall, in terms of energy, it will be an exothermic reaction, and the category of the reaction is known as combustion or burning. Respiration, when we use the glucose and oxygen produce carbon dioxide and water, opposite of photosynthesis, it will be exothermic. So now I want everyone to participate and identify whether these reactions are endothermic or exothermic. The first one, melting of the butter. Is it endo or exo? Melting of butter. A butter melts. What kind of reaction is this? Endo or exo? Melting of the butter. Melting of a butter means it will be butter will be there in a solid state and it turn into a liquid. A solid is turning into a liquid. So when solid turn into a liquid, how the solid can be turned into a liquid? By absorbing the energy. So melting of the butter is an example of endothermic reaction because a butter will absorb energy, the particles of a butter move away from each other and it will change the state. So the answer for melting of butter is endothermic. Is it clear, the first example? And I just mentioned, if you remember the examples which I mentioned from the beginning, endothermic when solid turn into a liquid, liquid turn into a gas, solid turn into gas. These all are endothermic, dissolving of salt, thermal decomposition, electrolysis, and photosynthesis. So when the butter melts, it absorbs energy, and that is endothermic. The second example, boiling of water. When we boil the water, what kind of reaction is this? Boiling of water. You have a container that is filled with water. So boiling of a water, you want to convert the liquid state into a gaseous state. So what we have to do to boil the water, Yeah, what about others? I expect participation from others. Yeah. So we have to supply the energy, we have to heat it. So when we supply the energy, heat energy is supplied, the liquid will turn into a gas. So boiling of the water is an endothermic change. Another question, burning of hydrogen. When we burn hydrogen, I will write the equation that hydrogen is there. It is burned in the presence of oxygen to give water as a product. So because burning is there, combustion is there, whenever combustion or one of the reactant is oxygen, the reaction will be exothermic. So this example will be exothermic. It will release energy. Then formation of glucose by green plants. The formation of a glucose by green plants, the equation, basically it's photosynthesis. So what we have carbon dioxide plus water. So when carbon dioxide and water mix with each other, this is photosynthesis. So carbon dioxide plus water, this result in a formation of glucose plus oxygen. Oxygen is not the reactant, oxygen is a product. So what kind of reaction is this? Photosynthesis, because they absorb the energy, these green plants absorb the energy and then forming glucose. The light energy is absorbed. That's why this is an example of endothermic reaction. This is not exo, it is an endothermic reaction. Then another example, dissolving of sodium chloride crystals in water. So when we dissolve the sodium chloride crystal in water, what we have to do? We have to supply energy or the energy will be released. We have a container that is filled with water. So to dissolve the crystals, like when we even you add salt, the salt will not dissolve by itself. What you have to do, using a spatula or using a spoon, you have to stir. So basically when you stir, when you mix, you're supplying energy, and when you supply energy, what we call this type of reaction, we call that as endothermic reaction. Is it clear, the concept of endo and exothermic reaction with their examples? Anyone having a doubt or a question? So it is important you learn these examples so that directly you can identify the changes. So I'll write the examples again for endothermic reactions and for exothermic. melting when solid convert into liquid, boiling when a liquid convert into gas, sublimation in which a solid turn into gas, dissolving of salt, photosynthesis, thermal decomposition, electrolysis in which we supply electrical energy. These are examples of endothermic. And what about exothermic? Combustion or burning, condensation, freezing, sublimation in which a gas turned to solid, and respiration, and a chemical cell in which we use two metals, electrodes, difference in the reactivity produce electricity. These are exothermic reactions. So reaction in which energy is absorbed, endothermic, overall energy is released, that will be exothermic. So this is the first part of the topic, that you should be able to understand the reaction in terms of the examples. The second part is energy diagram for exothermics and endothermic reaction. So how we draw the energy diagram for the endothermic reaction. So the energy diagram for endothermic reaction, x-axis we write reaction progress, on y-axis we write energy. So what is the energy diagram? It is fixed for all endothermic reaction. You have to learn the labels as well. So for endothermic reactions, the reactant will have low energy, and the product will have high energy, because the reactant absorb energy to form a product. So reactant will have low energy and the product is having high energy. How we represent this diagram, what happened during a chemical reaction? First, because in endothermic reaction, the term endo means heat energy is absorbed or energy is taken in overall. So first what happened? The reactant absorb energy. When these reactant absorb energy, they will not start the reaction instantly. They will take time to react. So the moment, the point where the reaction started, the position where this reaction start, what we call that position is known as activation energy. So the point where the reaction start, and once the reaction started, the reactant will form a product. So the labels which you have to learn, Number one, the activation energy. What is the activation energy? The arrow from reactant to the start of the reaction, which we can say level A. So arrow which is pointing from reactant to the start of the reaction, the position where the reaction start, what we call that? We call that as activation energy. What is the meaning of activation energy? Activation energy means energy at which the reaction starts, the point where the reaction start and reactant start to form a product, we call that as activation energy. And the arrow from reactant to product, when we draw an arrow, sorry, from product to reactant, when we draw the arrow, what we call this arrow? This is known as energy change, also known as enthalpy change. So this is a diagram, energy diagram of endothermic reaction. What happened in endothermic reaction? Reactants have low energy, product is having high energy. First, what happened during a reaction? Reactant absorb energy because it's an endothermic reaction, so reactant absorb energy. Once the reaction absorb energy, there will be a point where the reaction start. So energy from reactant to the start of the reaction, that energy is called activation energy. And once the reaction started, the product will be formed, and the arrow from reactant to the product is known as energy change during a chemical reaction, or also known as enthalpy change. So exam point of view, you have to learn all the labels of this energy diagram for endothermic reaction. So you have to memorize, learn these labels for endothermic reaction. Any doubt till this point? Any question or a doubt for the energy diagram of endothermic reaction? So a chemical reaction can be an endothermic, can be an exothermic. So basically you have to learn this diagram for the endothermic reactions. So what are the labels you have to learn? You have to memorize this diagram for an endothermic reactions. On y-axis you have energy, on x-axis you have reaction progress. These positions are always fixed, it won't change. So reactants will have low energy in endothermic reactions, and the product which will form will have high energy. So what happened? The reactants absorb energy, and as the reactant absorbing energy, their energy is increasing, and at a certain point they start the reaction. Yeah, it will not start with the bottom because reactants still have some energy. So it's not starting from the origin, it is above the origin because reactant have some energy. If I start from below, like on the origin, it means reactant energy will be zero. So reactant have energy, the point where the reaction start, and they will form a product. So the position where the reaction start to the reactant, the arrow, what it represent activation energy. That's called the activation energy. and the arrow which is pointing from reactant to product. So arrow which is directed from reactant to product, what we call this arrow, or how we label this arrow, this arrow is known as energy change. So you have to learn this energy diagram for an endothermic reaction. There is a, for exothermic as well. I'll continue this discussion of energy diagram in the next session.